So this morning we're going to do something a little different. We're going to talk about electric toothbrushes. This is in support of a project with the folks at the University of Missouri at Columbia who are adapting electric toothbrushes for folks who don't have the hand strength in order to push the buttons on these things. So the original design, which used a larger toothbrush design, had a really neat idea. It had a reed switch in there that was magnetically activated. So when you lifted or moved the toothbrush either away or towards the magnet, it would turn it on and off. That was really cool. But that required kind of adapting that specific toothbrush, and it wasn't a more general solution. Well, while they were talking with folks and people overheard, and somebody said, well, why don't you try using a AAA battery instead of the standard AA that are in these things? And that'll give you a little more space. So we've been kind of working through some ideas on how to do that. And here's what I've come up with so far. The first thing you need to do is you need to get all the measurements for these batteries, and you can find that all online and model them. And I first started out with the most basic setup, which is basically a cylinder within a cylinder. And I realize it's real hard to see this black PLA. PET. I'm going to show you it on the CAD in a second. So the outer one is the size of a AA battery, and then the inside cut is the AAA battery. And the idea is that you take out the AA, you put a AAA into this adapter. The adapter would go in to the toothbrush like that. And then what would be added is a little tough to get out here. What would be added is cutting away some of this to put some sort of sensor like a reed switch, and in effect putting a battery interrupter. Now you could, those with careful eyes can see that there is really not a lot of space for us to put in some sort of interrupter. And we can't really use a traditional interrupter that you see made out of flexible printed circuit board material, because we're going to be wiring it up differently. We want this to be able to be made also by hand. So what you could do is you could purchase some of these little, of course on Amazon, purchase some of these sets of AA, AAA size metal tabs. So we could start out with these. And at first I thought I was going to have to do the spring and the top. Then I realized I don't need the spring because we're only disconnecting one. So the first thing I did with the design is I said I don't need the spring. Put it away. And instead I made a hole in the bottom of the cylinder so that the negative pole is exposed. The negative battery side is exposed. And of course this has all its own measurements too, this is an exercise in small measurements. So let me show you the model, because then it will make more sense, I think. Let me switch this over and put that over there, and let me bring over my OpenSCAD, because of course you know me, I used OpenSCAD. So here we have the model, and OpenSCAD is perfect for these sorts of things because it's very measurement dependent. So I grabbed measurements off the internet of what typical batteries are, and then I also grabbed measurements with my digital dial caliper of the size of these little metal tabs. Their height, their X and their Y. They're about 9.7 wide by about 9 deep, and they're 0.4 millimeters tall. And I measured the tab that goes on it and everything else. So you got to get all those measurements. And then I had models for each of the types of batteries. So it's very simple. The AA battery is a cylinder, and its diameter is whatever, and its height is whatever. The same thing with AAA. So this is not taken into account the it's not an exact model. It's not taking into account the top tab and all the other little measurements, but it's close enough for this sort of work. Well, the first thing I thought once I had the two cylinders is I need to actually get a way to get the battery inside. So I had to cut away an extra slot here, and this is where you see this AAA opening thing. This is a cube, and let me turn this cube on temporarily so you can see it. So that's a cube in the model that I subtract out so that I can actually insert the AAA battery. If I didn't have that, well, you'd have nowhere to put the battery. That would be a little tough to upgrade in the field, right? So put that in, and then that's when I had the spring idea that I didn't need the spring in the bottom, because I realized how little wiggle room I have at the top and bottom. And so that's where I put the cylinder for that, and it's an 8mm cylinder that allows the spring to poke through. Okay, so far so good. Now the really annoying part is trying to use these off-the-shelf metal tabs. And for that, again, I created a model for what the slot is. And the slot is a cuboid, which is the square part. And then it's another cuboid, which is the tab, the metal tab that sticks out for you to solder to. And that model gets built and then subtracted out of the top of this. So it's shifted down 1mm and 2mm because one of them has to face up and one of them faces down, because this is an interrupter, so there's two connections up here. Let me show you what that slot looks like modeled. See, so there's how modeled it looks. And again, just like the battery, I had to have that additional slot opening so that there's actually a place to slide that part into for assembly. Otherwise, again, you can't get to it, and that would be bad. So let me remark this out. So here we have the two, and you can see one is facing down, so that'll touch the top of the AAA battery, and this one will have it facing up, so that it could touch the contact within the toothbrush. A couple of other things. One, I did put a variable on here for a tab offset, because in final assembly, you will have two metal tabs sticking out here, so they're going to be hard to solder. So if we needed to, we could offset the two parts so that they come out at different angles, just in case. Right now I have it like this. All right, the next thing in this trail of tears is how the heck do you actually print this? This is a good example of a item that is really hard to print. If you print it upright, you're going to need supports throughout all this, and you've got really tight tolerances. These are pressing the bounds of traditional FDM printers. This is probably something that would be best printed on a resin machine. So anyhow, you all know that I absolutely abhor supports, and I will do anything I can to avoid printing supports and removing supports, because I hate supports. Can you tell I don't like supports? So what I did is something I've done in other designs, and something I could do here pretty easily, and it fits two purposes, is I sliced off the back of this circle and made it a flat plane. And doing that, and here I'll make this visible too so you can see how that slices. See, it's just a subtraction off of there. This allows me to lay this piece flat and print it flat on the bed, which makes for a much better print. And I'll bring over my simplify screen here, and you could see what I've done. The model comes up standing up straight, and I change the rotation so that it lays flat on the bed like that. So it prints like that. And let me move this out of the way so you can see as it's building it, it's a pretty straightforward build. The bottom is wonky. You could see the first couple of layers there. This is where this layer preview is real handy, because you can see how it's actually laying it down. And you've got an overhang here and a bridge, semi-bridge there. That makes it a little bit stringy, but it prints not bad, not great, not terrible, not perfect. But for a starting point, it's pretty good. And this, and you can see here, because my tolerances have gotten beyond what the printer could do, what in the model, let me hop over the model real quick, what in the model, this top should be covered, right? And when you look at the, oops, wrong screen, too many screens. When you look here, it's not. So it's always a good idea, make sure to preview your model and go over it and see how it's going to print and what the printer is going to do, because that's a problem. So now I've caught this, so I was just about to start this to print, and I'm glad I did this video, because now I know I need to fix the model. But it also shows the crazy tolerances we're trying to deal with here. And this may be a case where I can't use that off-the-shelf metal part. I may have to use like a piece of printed circuit board or something similar, or maybe like a battery interrupter. Maybe a battery interrupter will be the answer. Is if it's small enough, I could slide it in here and then just attach it. And the other thing I want to do to this model eventually, once I get it printing okay, is try to carve out more space on this back to actually put the reed switch or the or whatever we end up using. So this is kind of an experimental thing. I don't know if it'll actually turn into anything, but while I'm waiting for other 3D prints to complete, these are good little projects for me to dive into and start thinking about. It's good if you don't have a long attention span like me. You can hop around between different projects. Actually, I say that. I have a very good attention span, but I like to work on about 30 things at once. I get bored easily. That's how I put it. So there you go. That's what's happening so far. This is a long video about a toothbrush and a battery, but hopefully it has proved helpful in thinking through this problem. Thanks for watching.